how they work. And by the way, T is called the parameter. Mostly for us, I think you'll have to do a little bit of this on tonight or tomorrow night's homework. Mostly we are going to graph parametric equations on our calculator, and we're going to do some applications with them later. But just so you understand how they work, I'm going to give you a set of parametric equations. Okay. And what we're going to do is we're going to graph these. And I'm going to give you some points that we're going to plug in. Okay, so let's graph it. I would have to give you a range, like for T, because T can be anything. I'm going to say let's graph it for -1 to 1. And so what we do, and I'm going to just use a scale of 0.5, is we plug in our T, but we plug it into X to get the X coordinate, and then we plug it into Y to get the Y coordinate. So let's say I started with -1. Alright, so let's plug it in up here. What's -1 squared? -2 is -1. And then to get Y, I put -1 in for T here. Okay, so what ordered pair does that give me then? -1, -3. This is used to find points. T does not show up in the graph. The graph is still an XY graph. It is used to generate points. So let's just do this with the remaining points. So -0.5 squared -2. And then if I put -0.5 in here, I would get -1.5. Is this making sense so far? Okay. And so then I would graph this point. Alright, so when I plug in 0, I get over here -2, and over here, remember I'm putting 0 in, I get 0. So when I put 0.5 in, I get -1.75 up here and +1.5. So now let's take a look at what happens when we graph these. So now that I've used this parameter, I'm not going to even use those when I graph. I'm going to use my ordered pairs. Can you tell what this is going to be? what does it look like? Okay. If I were to continue graphing. A parabola, but it's opening sideways instead, right? Okay. So let's just take a look and put them. Let's talk about putting them in our calculator a second, so you see how that works. If you go to mode, there is parametric mode, and you have to be in parametric mode, because then what your calculator will do is instead of a y equals, it will have an x equals and a y equals, because that's what we need here. So let's go to parametric mode. And so you can see this, when you go to y equals, do you see this popping up? Okay. And then it will have, normally the default, when you type in this button, this xt theta n, the default is to put an x, but now that we're in parametric mode, your calculator will make that a t. So if I did t squared, oops, I want to do that in y, t squared minus 2, and then 3t, okay? But then the window is a little bit different, because not only do we have to pick x and y, what else did we have to decide here? What to pick t. So I go to window, and you notice they have this t min, t max. So for me, what did we do? We went -1 to 1. Now I made this 0.5. I'm going to show you what happens when you make it 0.5 in a minute. Okay, and then for our window, let's just make a standard window. So -10 to 10. And -10 to 10. Okay. So, a couple things. What do you notice that happens then? It stops. If you would make t go like from this, -2 to 2, it's going to go a little further. A little further still. Okay. So if you don't pick a big enough value for t, you won't get your whole graph to show up. If you pick anything that's bigger, like I picked 0.5, all it will do is that basically your calculator calculates every half point and then it connects to that. So if you start making that too big, like this, what ends up happening is it doesn't look like a curve, because your calculator doesn't know how to do that. It looks jagged. Do you see how kind of it's looking a little more jagged there? So you want to kind of keep that t-step pretty small on your calculator to make it look like a curve. Okay? So we haven't talked about these yet. This is new. Okay. Then let's just, last thing we're going to talk about is how do I get from this, which is parametric mode, to a function, and we call this eliminating the parameter. So what's the parameter again? T. And so if I ask you to eliminate the parameter, all that means is get rid of t. And this is why it is talked about in chapter 1, because what this ends up being is a composition of functions. I'm going to put one of these functions in for the other function, essentially. So let's just do the one we did. This means to get rid of t. So what we are going to do is we're going to take our two parametric equations, and we are going to get one of them so that t is alone. Okay, so for instance, this one I could add 2 and take the square roots. I think this one seems a little easier, so I'm going to get t alone. I'm going to divide both sides by 3. And then I'm going to use substitution into the other equation. Okay, so what what did we say t is the same as? T equals y over 3. So over here, I'm going to then put y over 3 in for t. Remember, I'm squaring t, so I'm going to be squaring y over 3 minus 2. So I square that. And if I wanted to simplify a little further, I could do y squared over 9 minus 2. Alright, so now do you see how I have an equation with just x and y? And so I've done what I asked you to do, which is eliminate the parameter. By the way, I hope maybe you remember this from equations, like when you did the section on ellipses and things. An x equals y squared is a parabola on its side. Just like if we had y equals x squared, that's an up-down parabola, and x equals y squared is a parabola on its side. And so if we were to graph that, now using ordered pairs, you would get the same thing. So that's really how parametric equations work.